Animating game characters is a vital aspect of game development that transforms static figures into dynamic entities, making the virtual world come alive. Today's lesson will guide you through the fundamentals of animating characters in games. We'll focus on moving them seamlessly within environments, applying different animations, changing outfits, and implementing collision detection systems. With these skills under your belt, you'll be able to create immersive experiences for players, making them feel like they're truly part of that game world. So, let's dive right in! Now, let's take a look at how we can implement a basic character structure that facilitates movement in our game. We start by defining a character structure that holds essential properties like the character's position, those are your X and Y coordinates, and speed. The constructor allows us to initialize a character's starting position and speed when creating an instance. Next, we define several movement functions: move up, move down, move left, and move right. Each of these functions adjusts the character's position based on the speed value, thereby translating user input into actions within the game world. For example, calling move up increases the Y coordinate, moving the character upwards. This system enables players to control the character's movement seamlessly based on keyboard inputs. Deep breath in. Additionally, we illustrate how to create an instance of character, initializing it at the origin 00 with a speed of 0.1. In the game loop, we can call these movement functions to respond to player inputs, allowing for smooth navigation through the game environment. This foundational concept is crucial for character animation, forming the backbone of interactive gameplay. Now, let's dive into how we can implement the animation system for our characters. In this segment of code, we define an animation state enumeration, which represents the different states our character can be in, like idle, walking, and jumping. This enumeration is really important because it helps us manage and switch between these animation states in a clear and systematic way. Next, we create the animation class, which will take charge of the character's current state and oversee how animations are updated based on that state. When we initialize this class, we set the default state to idle. Now, within the class, the update animation method becomes key. It contains a switch statement that evaluates whatever the current state is and can trigger the relevant animation frame logic for each state. This setup means that as our character transitions from one state to another, we can efficiently update the animations accordingly. For practical implementation, we create an instance of the animation class and show a state change by setting the character to walking. This change in state is linked to the player's input, providing visual feedback in the game and making the experience much more engaging. Now, let's implement the Character Outfit class, which will enable our characters to dynamically change outfits during gameplay. This class is designed to hold the current outfit's information, represented by a string called outfit name. The constructor initializes the outfit with a provided name, setting the stage for effective outfit management. Next, we include the Change Outfit method, which is pivotal for altering the character's appearance. When invoked, this method updates the outfit name with a new value, allowing characters to seamlessly transition from one outfit to another. It's essential to consider that this method not only updates the outfit's name, but also acts as a trigger point where developers can load new textures or models specific to the new outfit, enhancing the character's visual appeal. By utilizing the Character Outfit class, players can enjoy a richer customization aspect, deeply engaging them in the game world. For example, starting with the basic outfit, players can switch to something more elaborate like warrior armor, reflecting their progress or choices made within the game. This dynamic change, it really adds depth and personalization to character interactions, which is vital for modern game design. Now, let's implement a basic collision detection system to ensure our characters interact appropriately with their environment. The check collision function is designed to determine if two rectangular areas overlap using a method known as axis-aligned bounding box, or AAB detection. This function takes the character and the target's position and dimensions as parameters. So, what happens within the function? Well, we perform comparisons to check whether the character's current position intersects with the target's area. Specifically, we need to check if the character's x-coordinate is less than the target's right boundary. And similarly, we assess the y-coordinates. If all of these conditions are satisfied, it implies, aha, a collision has occurred. Next, we can use this function to manage interactions upon collisions. For instance, when the character collides with another character, we can trigger specific responses, like stopping the character's movement. This collision handling enhances gameplay realism and interactivity, enabling players to have more engaging experiences. Isn't that just what we need for a captivating game? In a more advanced implementation, you can truly enhance your collision detection by introducing physics. Physics engines are amazing because they can simulate realistic interactions with forces, gravity, and friction at play. If you're using a library like Bullet, or if you're integrating with engines such as Unity or Unreal, make sure to explore their physics components. They really open up the door to more sophisticated interactions. But, if you're working on simpler projects, sticking with manual collision checks works perfectly fine. It's all about choosing the right tools for your specific needs. Now, let's dive into how we can implement character interactions within our game using an Interaction Manager class. This class is specially crafted to manage actions that unfold between characters as they get close to each other, enhancing the gameplay experience through cooperative actions like dialogues or trades. The heart of this class is the interact method, which, just to clarify, takes two characters as parameters. It kicks off by checking if a collision has occurred between the two characters, and this is done through a predefined collision detection function. This function evaluates their positions and dimensions to see if they overlap. So, if we detect a collision, it means these characters are close enough to interact, giving us the green light to trigger various interaction mechanisms, such as starting dialogues or initiating trades. This structure is fantastic because it encourages a clean organization of the interaction logic, allowing us to keep character interactions separate from other functionalities, like movement or animation. And by implementing this approach, we can really enrich the gameplay, making it more engaging and immersive for players. Because, let's face it, interactions are often the backbone of dynamic and collaborative gameplay elements. At this stage, you're equipped with the foundational tools for animating game characters effectively. This includes handling movement, animations, outfit changes, collision detection, and character interactions. Mastering these concepts will greatly contribute to your skills as a game developer. So let's break these down a bit. Handling movement, for example, is all about how your characters traverse the game environment. And trust me, getting this right feels super rewarding. Then there are animations. They bring your characters to life, making their actions look fluid and realistic. Outfit changes? They can add so much flair, enabling your character to express different styles throughout the game. Now, collision detection. That's crucial. It ensures that when characters bump into objects or each other, it feels natural. Understanding how to set these interactions up can elevate your game immensely. So keep practicing, and soon you'll be weaving these elements together seamlessly to create dynamic and engaging gameplay experiences. All right, let's take a moment to recap what we've learned so far. We dove into character movement mechanics, crafted an animation state system, explored outfit customization, and made sure that our characters can engage with their surroundings and each other thanks to robust collision detection and management systems. So, as we look ahead, the next steps are all about refining these systems even further and linking them to a user interface. This connection will provide essential feedback and controls to the player, ensuring a seamless gaming experience. Each step you take in character animation and interaction really lays the groundwork for those immersive narratives and engaging gameplay that players simply crave. So, get out there, experiment with your characters, and continue honing those skills in game character animation. Who knows? You might just create the next memorable game character that players absolutely adore.